Greetings, math fans. Alright, so today we're going to talk about something called circular functions. Okay? And basically, angles are measured in degrees, which we talked about in the first two chapters, and then the chapter we're talking about now is radians. Okay, so let me just write that down. Angles are measured in degrees and radians. Okay, so the degree, talk about a few things here. Degree domain, okay, is your angles, and your radian domain are real numbers. Okay, and that's kind of what we did, right? Everything's kind of in terms of pi, but it's a real number. It's not an angle. Has actually no units, right? We talked about that. So, and this one's actually a little more useful. As we talked about this already, it's useful in basically in engineering and a lot of different sciences and math. All right, so we're going to really base a lot of this off of a unit circle. Okay, and if you guys remember, a unit circle has a radius of 1. So we have S equals R theta. This is a nice little formula that we have learned already. And so basically S equals theta. So S being your arc length, and so this means that theta is going to be measured in radians. Kind of stuff we learned already. Okay, so let's clear this out here, and I want to talk about a couple things here now. If I said, this is actually from page 119 in your book, but if I say sine of S, because now we're saying instead of theta we're using S, sine of S, you guys remember that the original ratio I taught you like on day 2, that's y sin, so it's y over r. Oops, y over r, okay? Well, if r is 1, right, for this one, r is 1, because we're talking about a unit circle, that means it's equal to y. And cosine of S is equal to x over r, so again, that's equal to x. Tangent of S doesn't change because it's just the ox. And then, of course, you have your reciprocal functions. Cosecant of S is r over y, which is just 1 over y. Secant of S equals r over x, which is equal to 1 over x. And, of course, cotangent of S is the equal distant cousin, the xy, which doesn't change. Okay? So, y, the value of y, and the value of x, they are both between, if you guys remember, what's the biggest value that sine can be? Okay, you guys agree the biggest value is 1 and the smallest value is negative 1? So there we go. The smallest value is negative 1, the biggest value is 1. So these values are between 1 and negative 1. So the sine of S, which it's the same thing, where y is the sine of S, right? Sine of S has to also be between negative 1 and 1. And cosine of S has to be between negative 1 and 1. Okay? So S is the domain, or S, the domain for these functions. So S, domain for these functions, right? Your input actually can be all real numbers. That's the symbol for all real numbers. So all real numbers. Okay, that's the domain. And of course the range is between negative 1 and 1, right? It's like saying y equals, let's go back to our old thing here, y equals sine of theta. That's our value of S, right? So that's the input, that's your domain. And this guy here is your output, which is your range. So This guy right here is the range. And this guy here, all real numbers, is the domain, because it can be any value, right? I can plug in anything I want into that. I can say sine of 10 pi, sine of 105, sine of anything. Could be anything. Okay, so let's relate theta to s. Well, since sine of theta is equal to y over r, which is equal to y, right, when r is 1, well, that's just sine of s. So it's kind of a basic thing here. I'm just relating and telling you that it's kind of the same thing, right? Same thing with cosine. Cosine of theta equals x over r, which is x, which is cosine of s. So these are the same as well. Okay, so since really these are the same, it's the same ratio, no matter if you use theta or s, we can say, we can treat radians like degrees. Okay? So what I want to do is I want to actually do some problems with our graphing calculator now to talk a little bit about what's going on here. Before I actually get started with a problem, what I want to do is I want to do one quick problem here. The question is, how far around the unit circle is 21 radians? All right, it's a good question. Well, you guys already know, if I draw, we kind of go around the circle here, right? If I go here this much, isn't it pi radians, or 3.14? And I go around here and I get to 2 pi radians, which is 6.28. Do you guys agree with that? So when I say how far around, really what I'm looking for, I want to find the quadrant. That's my goal here, math fans. I want to find the quadrant. So there are two ways to do this. I'm going to show you the tough way first, and then I'm going to show you the easy way. Okay, the tougher way is to say, well, if it's 6.28 going around, what happens if I go around again? Okay, well, isn't it 6.28 times 2? Well, how many times can I go around, like coterminal? And it's truly what I'm doing is I'm subtracting 2 pi from this to see what quadrant I'm in. So how many times can I go around? Well, doesn't it make sense I probably can go around 3 times? Okay, and let's just make this, instead of 6.28, let's make it 6.25. It's still about 2 pi. So do you agree? I do coterminal and I subtract 2 pi, so I subtract 6.25, I subtract 6.25 again, I subtract 6.25 again, and if I do that, I subtract 18.75 from 21. Okay? And that gives me 2.25. Do you agree with that? Left over? So this is the deal. I've gone around, but I'm back over here again, and I got to go 2.25. Well, what's pi over 2? Isn't it half of pi? Which, 3.14 divided by 2, it's about maybe 1.6. And this is 3.14. So isn't 2.25 somewhere over here? So the answer to this problem is it's in quadrant 2. Okay? That's one way to do it. This is probably the better way to do it. I just want to show you that because I want you to kind of investigate a little bit. The better way to do it is, what if I take the sine and cosine of that value? So let's do that. If I take the sine of 21 radians, so let's bring up our calculator. Make sure you're in, I'm in wrong mode here, right? So I'm going to change it to radian mode. Quit out of here. And then I'm going to do the sine of 21 radians. Close your parenthesis, it's a good habit. Hit enter. Positive 0.84. So let's write that, 0.84, but it's positive. Okay, so let's do cosine of 21 radians. See what we get for that. So cosine of 21 Negative 0.55. Negative 0.55. So it's negative. Okay, based on all students, it's probably Yachts over here, but it is here. You can move that down a little bit. Okay, but based on all students take calculus, which one is sine is positive and which one is cosine is negative? Well, isn't sine positive obviously here and here, and cosine negative is here and here, so my answer to this problem is right here in this quadrant, right? So it overlaps. That's actually the easiest way to do it, math fans. So again, my answer is quadrant 2. Just take the sine and cosine of that radian. Now this was easy for 21, but what if I gave you some nasty one? Let's give it to you. What if I said, what quadrant is radian measure of, I don't know, 1,523? Just made up that random number. You're like, oh man, if you got to subtract 2 pi from that every time, it's brutal. Well, let's do the sine and cosine of it. So 1523. Let's bring the calculator up. Sine of 1523. Okay, it's positive. I'm not even going to write the number down. So it's positive. And sine of, or cosine of 1523. So let's actually just bring that up again. And I could have just typed it in a bit faster, right? But that's okay. Cosine of 1523, and that is negative. Okay, so this one's negative, and we're in quadrant 2 again. That's kind of nice. Okay, it was really easy, very, very simple to do it that way. Okay, not too bad. So I would say this is definitely taking the trig function is definitely a better way to figure that out. All right. So we're going to use our calculator now. So using your TI graphing calculator. So make sure you have it out and follow along here, okay? The key thing here, math fans, it's got to be in radian mode. Okay? In physics, you change it to degrees, so make sure you put it back to radian mode. Super important. So guys, there are 4 kinds of problems we can have using our graphing calculator. All right? So let's do a couple of them here. If I said the sine of 0.405. This is the first, so I'm going to label this the first kind. This is the easiest out of all of them because you literally type in your calculator. Let's go to our calculator here. Okay, so sine of 0.405. Hit enter. Enter. And let's round to 2 decimal places just for the heck of it. It's 0.39. Okay, so make sure you round correctly. So that's easy. 0.39. Really easy. Guys, just remember rounding. If it's tenth, it's 1 place. If it's hundredth, it's 2 places. Thousandth, it's 3 places. 10,000th, 4 places, etc. So just watch rounding. It's a crummy way to lose points. Okay. Anyway, so the first one's it's really easy, right? Sine of 0.405. Let's just do another one of the same type, right? If I said tangent of 0.105, so let's do that. Tangent of 0.105. Okay. Oh, 0.105. So 0.11. That's kind of nice. 0.11. Let's do one more. How about cosine of, let's do a bigger number. You don't have to put small numbers. We can say the cosine of 4 radians. Right? That's pretty reasonable. Okay, so let's take a look at that. Cosine of 4 radians. Remember, these are all radians. Hit enter. Negative 0.65. Okay, negative 0.65. That's the first kind of problem. That's a really easy kind of problem. Okay, the second kind of problem is you got to do a little bit of work. What happens if I give you cosecant of 0.405? All right. This is, if you guys remember, this is from chapter 1 and 2. You never, first of all, this is a radian measure. It's just like a degree measure. You never, ever, ever take the reciprocal of that value. Ever, ever, ever. Okay? Because you know we did everything in terms of pi? So watch. If I said cosecant of pi, you don't write this as sine of 1 over pi. It doesn't make sense. This has no relationship with 1 over pi. It's like going to Baker Square and saying, yeah, I'd like a pie, and my friend over here would like 1 over pi. They're like, what? What do you mean 1 over pi? But if you went over there and said, oh yeah, I'd like a pie, and my friend would like a half a pie, that's a different story. Okay? But don't ever take the reciprocal of an angle or a radian measure. It doesn't make sense. So if you can remember what you do from back in the day, you're doing this. 1 over cosecant goes with sine. Sine of 0.405. Okay? So on your calculator, just be careful. Type it in 1 divided by sine of 0.405. So let's do that. 1 divided by sine of 0.405. Hit enter. 2.5. 2.54. So it's equal to 2.54. Okay? Pretty easy, right? But remember, that's with the reciprocal functions, right? You got to do the reciprocal of that whole value. So let's do one more. Cotangent of negative 1.234. Oh, geez, we got a negative in there. Oh no, what do we do with the negative? Type it in. Okay, that's not a big deal. Don't have to worry about negatives. Negatives are cool. Just type it in. But of course, you got to rewrite it first as 1 over tangent of negative 1.234. Okay? So that's 1 divided by that. So let's type that in. 1 divided by tangent of negative 1.234. Enter. So it's negative 0.35. Okay? It's pretty easy, right? Not a big deal. Okay, so that's the second kind of problem. Third kind of problem is this. I ask you to find the value of S. Okay? And guys, for our calculator purposes, we're pretty much going to do between 0 and pi over 2. All right, it's when we're going to get to some problems later on where it's not between 0 and pi over 2 and you got to find your reference angle and etc. But for the calculator, just going to do between 0 and pi over 2. So here it is. Sine of S is equal to 0.572. And you want to find S. All right. Well, what did we do before? We used inverse sine. That was really easy. So we do S is equal to inverse sine of 0.572. Remember, use the inverse button when you're looking for an angle or a radian measure. Okay? So let's do that on our calculator. Let's just kind of clear this here. So it's inverse sine, second sine, okay, so that little minus 1 there, of 0.572. Close that, hit enter, 0.61 radians. So S equals 0.61 radians. Okay, you don't even have to put radians because remember, a radian is unitless, so you don't even have to write that down there. But it's okay. 0.61 radians. Okay, well, that's pretty easy. Let's do a couple more here. Tangent of S is equal to 1.428. Okay, so we just say S equals inverse tangent of 1.428. So S equals, let's do it again here, inverse tangent of 1.428. Close parenthesis, and voila, 0.96. S equals 0.96. Okay? So that's the third kind of problem, and that's pretty easy. You're just doing inverse trig functions, and it's pretty mellow. The fourth type of problem is this. What if I told you secant of S is equal to 1.835? All right, well, it's a different kind of problem because we don't have an inverse secant button, right? So what we do is, what I always tell you this is, math fans, I always told you this is a ratio. Okay, when I taught you sine of S, I said it's y over r, cosine of S, x over r. So secant goes with cosine, so instead of r or x over r, this is r over, or instead of x over r, it's r over x. Okay, so what you can do is you need to rewrite this first. And I need to write this in terms of something I know, which is cosine of S equals 1 over 1.835. Now this is like number 3. That's all it is. It's just like number 3. So what I'm going to do is I'm going to do the inverse cosine. So S equals inverse cosine of 1 over 1.835. Okay? That's all you do. But you got to rewrite that into a ratio. That's really, really important. Okay, so let's do that. Inverse cosine of 1 divided by 1.835. Okay, hit enter, and 0.99. Okay, so S equals 0.99. That's cool. Okay, let's do one more here. Cotangent of S is equal to 4.659. Okay, well, okay, let's just rewrite it. So we're going to say, instead of cotangent of S, we're going to say tangent of S equals 1 over 4.659. Okay, please don't do this. Don't say, don't do 1 over tangent of S, right? That's only if it's actually, if you look at number 2. Number 2 is if it's cotangent, you do 1 over the whole thing. Different. That's why you have to put that together. You've got to be careful what you do. So this, what I just circled up here, math fans, this is not a ratio. When I say cotangent of negative 1.234, that's not a ratio. That's like saying cotangent of 30 degrees. That's not a ratio. But if I said, like down here, I said cotangent of S equals that value, that is a ratio. Okay? Cotangent being the evil distant cousin, the xoi. So it's 1 over, or this is, I was trying to say what it wasn't. Okay, so this is rewritten here. You guys agree with that? So what I'm going to do is I'm going to say S equals the inverse tangent of 1 over 4.659. Okay, so then we get S equals, well, let's do it. We have inverse tangent, so second tangent of 1 divided by 4.659. And we get our favorite district, District 211. We'll round it to 1 or to 2 decimal places, so it's 0.21. Okay? So those are the 4 kind of problems that you guys can have. Just be really careful as you do those problems. All right? Okay, so this is not calculator anymore, but it's more of these types of problems where you have to find the angle or you are looking for the ratio. So let's do some more problems here. All right, so if I told you, let's just do a couple random ones. Sine of pi over 3. Okay, what's a reference angle? So this is all review. We did this like a couple days ago. So sine of pi over 3, well, isn't the reference angle, and I know you guys are still thinking in degrees, but theta is equal to 60 degrees, right? What's sine of 60? Isn't it root 3 over 2? So sine, so this guy here is going to be root 3 over 2. And where is pi over 3? Well, that's the first quadrant, so it's positive. So that's my answer to that problem. Okay, that's easy. It's right. First quadrant is always easy. How about cosine of 5 pi over 4? Okay, what's the reference angle? 45 degrees. What's cosine of 45? Oh, it's root 2 over 2. So I know it's at least root 2 over 2. Where's 5 pi over 4? Well, remember, 4 pi over 4 is right here. So isn't 5 pi over 4 just a little bit more than that? So it's in the third quadrant. Cosine, all students take calculus. So cosine is negative here. So the answer to this one is negative root 2 over 2. Yeah, it's not bad. Okay. Let's see. Let's try another one here. Secant of 2 pi over 3. Okay. Well, what's the reference angle? 60 degrees. And eventually I'm going to get you guys away from that. I'm going to say what's the reference angle? You're going to say pi over 3. But for now, you guys kind of know all the angles, which is cool. Okay. So secant goes with what? Secant goes with cosine. What's cosine of 60? Okay. Think back. Cosine of 60, right? Cosine of 30 starts at root 3 over 2, and it goes down to root 2 over 2, and then 1/2. So it's 1/2. So the cosine of 60 is 1/2. So what's secant of 60? It's 2. So this is equal to 2. Let's look at the quadrant we're in. Do you guys agree this is 3 pi over 3 here? So 2 pi over 3 is here. So isn't cosine negative? So the answer to this problem is negative 2. Okay? So, you know, a little bit of work, but just kind of, especially what I taught you the first day of this, showing that, you know, this guy here is 12 pi over 6 and 8 pi over 4 and 6 pi over 3. And on this side is 3 pi over 3 or 4 pi over 4 or 6 pi over 6, just to kind of help you figure things out. So if I said 11 pi over 6, you're like, oh, 12 pi over 6 is right here, so I must be in quadrant 4. Or if I said 7 pi over 4, oh, 8 pi over 4 is here, so we're over in this quadrant 2. We're in quadrant 4. Okay, or if I said 5 pi over 4, well, isn't this 4 pi over 4? So we're one more notch, so we're in the third quadrant. Okay? So that's kind of the scoop with that, math fans, with sines. But we've practiced it already. Let's do one more kind of a challenging one here. Tangent of 29 pi over 6. Brutal. Oh, man, it's brutal. Well, here's the deal. This is way over what we're used to, right? Okay? It's 29 pi over 6. And what you want to do is, just like if I said, hey, what is the tangent of 540 degrees? What'd you do first? Oh, I'm going to subtract 360. I'm going to do coterminal. So how do you do coterminal with this guy? You subtract 2 pi. So you could either add or subtract 2 pi. Okay, well, if I'm adding and subtracting 2 pi, remember in terms of pi over 6's, isn't that 2 pi is 12 pi over 6? And if it was over 4, it would be 8 pi over 4. If it's 3, it's 6 pi over 3. These are all 2 pi's. And this is, you're going to add and subtract those to do coterminal. So how many 2 pi's can you subtract from 29 pi over 6 without making it negative? Well, think about it. How many 12 pi over 6 is going to 29? 2 of them, right? Or 22 of those times 12 pi over 6 is 24 pi over 6. So truly, I'm going to rewrite this as tangent of what's 29 pi over 6 minus 24 pi over 6, which is 2 pi's. It gives me tangent of 5 pi over 6. So truly, math fans, this is my new problem. Tangent of 5 pi over 6. Okay? And what's the reference angle? 30 degrees. Sweet. Because what's tangent of 30? Okay? Three's rule here, people. So you know it's root 3 over 3. And where's 5 pi over 6? Well, isn't 6 pi over 6 right here? And isn't that a little bit less? Okay, so I'm in this quadrant. And tangent is what in that quadrant? All students take calculus? Of course, it's negative. So the answer to this problem, I'll put it up here. I'll even do it in red. Okay, the answer to this problem is negative root 3 over 3. Okay, so it's just, it's really not that bad. Get your reference angle, and what you're doing now, math fans, is you're, just once you get the reference angle, you're figuring out the sine, and then you're good to go. Okay, so that's it. So we got a couple more here, and this is again not using the calculator, just doing it manually. So let's clear this out of here. And what about if I give you this? Sine of s equals root 2 over 2. Well, here's the deal. I'm going to give you a restriction. So between 0 and pi. That means my values are going to be between 0 and pi, which means you're going to be between these two quadrants right here. Okay? So it's kind of like what we did before, math fans. Like if I said theta and I said, hey, sine of what is root 2 over 2? Well, wasn't that 45 degrees? And you could draw your triangle, but I'm trying to get you guys away from the triangle, which is the reason I asked you guys to memorize the sine of 45, the sine of 30, and sine of 60 at the beginning. Okay, but the sine of 45 is root 2 over 2. So I'm going to say theta prime is 45 degrees, but we're not really using that. We're saying s prime, the arc length, or s for radians, is pi over 4. That's what I'm looking for. You guys already know that, right? Pi over 4 is 45, right? Because that is 45. And pi over 3, it's opposite of that, so it's 60. And pi over 6 is the opposite of that, so it's 30. Okay? So if that's my reference angle, let's go back to this one here. I need to be in which quadrants are, first of all, do you guys agree this is positive? And it's all students take calculus. So which quadrants are positive? Well, isn't it in this one and this one? Okay, so what do we do before? Well, this is pi over 4. That's easy. What do we do for this one? What did you do when it was in degrees? Didn't you say, when it was in degrees, didn't you say 180 minus that angle? Okay, you all know what you're doing before. Well, it sounds like I'm going to stop. Y'all know what you're doing. Okay, but you all knew what you were doing before. You said 180 minus that angle. Well, this is not 180 anymore. What is it? It's pi. So you're either going to say pi plus a value here, or pi minus a value here, or pi plus a value here. Okay, so let's keep going here. So my one answer, it's kind of a little messy here. Let me get rid of this. Okay. For this quadrant, you're going to say pi minus pi over 4. Pi minus the reference angle. And it's, I don't care how you do it, get a common denominator. 4 pi over 4 minus pi over 4 is 3 pi over 4. So that's the answer. So there are two answers to this problem. Two places where it's positive. One answer is pi over 4, and the other answer is 3 pi over 4. Okay? Not that bad. Not that bad. Let's do a few more here. Cotangent of s is equal to negative root 3 over 3. So what I would do if I were you, math fans, rewrite it. It's a ratio. Rewrite it. Oh, tangent of s equals, if I do the reciprocal, you almost should know. It's just root 3, negative root 3. Okay? What's a reference angle? I'm going to write theta prime. Okay, it doesn't rule there, right? So it's got to be 60 degrees. So what is s prime? What's 60 degrees? Pi over 3. Because the 3 and the 6, right, go together. That's your reference angle. Oh, I forgot to tell you this. Naughty me. Okay, it's going to be between pi over 2 and 3 pi over 2. So what does that mean? Well, here's pi over 2 on top here. Here's 3 pi over 2. So it's going to be in one of these two quadrants. You agree with that? Where's cotangent? Going back to our original problem, where's cotangent negative? Isn't it negative here and here? So which quadrant, where's my only answer going to be? My only answer is going to be in this quadrant right here. Because of this, that line there, right, the arc line here, and knowing that cotangent is negative in the second and fourth quadrant. So my answer's got to be those yellow spiders right here. So what do? Well, the reference angle is pi over 3. What do? Well, pi minus pi over 3, which is 2 pi over 3. This one's got one answer, and that's my answer, 2 pi over 3. Okay? Be careful, math fans, of the restrictions. Okay? Let's try another one here. I don't have any more in my notes, but I'm just going to kind of make one up here because I think it's kind of important you guys see that. Okay, so let's do another one here. We have tangent of S is equal to -1, and it's between pi and 2 pi. This one's easy. Tangent of -1 is really easy. What's the reference angle? Pi over 4, right? It's 45 degrees, so it's pi over 4. And where's it negative? Well, we got two sets of restrictions here, math fans. This makes a restriction, and this makes a restriction. So between pi and 2 pi, isn't it between here and here? And where's tangent negative? Tangent is negative here and here. So where does it overlap? Right there, man. So it's quadrant 4. All right, so let's figure that out. This is our reference angle. Right there, right? S prime. So what we're going to do is, what did we always do before we were in the fourth quadrant? Didn't you always say 360 minus that value? It's not 360 anymore. What's that? What is that over there? Isn't that 2 pi? So we're going to do 2 pi minus pi over 4. And again, if you're not good with that, change that 2 pi to, how many pi's over 4 is 2 pi? It's 8. So 8 pi over 4 minus pi over 4, which is 7 pi over 4. That's the answer to that problem. S equals 7 pi over 4. Okay? So it's not bad, just got to watch everything. And you got to know just when to subtract from, again, this is 180, or let's get rid of that 180, right? It's really pi minus S prime. This is pi plus S prime. And this is 2 pi minus S prime in this quadrant. And this quadrant, the first is the easiest. That's just S prime. Okay, you don't have to do much work at all for that. Okay, so it's kind of a long explanation here, but it's got a lot of stuff to this, this part of the chapter. Just kind of watch those 4 steps with a calculator and make sure you know how to use it with and without a calculator. All right, that's it, math fans. Have an outstanding day. Adios. Goodbye.